The robot project has the potential to be more significant than the vehicle business over time. Elon Musk predicts, and if it comes true, the global workforce will enter a new era. 6-hour workdays with the same productivity as 8, farmers with time to experiment with new crops instead of focusing solely on harvesting. All of this could become reality when 1 million Optimus robots join the global labor force. How could Optimus Gen 3.5 make that happen? Before we begin, please help us reach 15,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. Why can Optimus do more work than humans at a lower cost? When Elon Musk announced the goal of producing 1 million Optimus robots per year, he was referring to an industrial-scale shift similar to what the Model T once brought to the automobile industry in the early 20th century. The Model T lowered the cost of cars to a level affordable for the middle class, and as a result, society transformed. Road infrastructure boomed, the transportation industry expanded, and millions of new jobs were created. Optimus could do something similar, but instead of expanding mobility, it will expand labor capacity. The key lies in cost. Musk aims to sell Optimus for under $20,000. Assuming a lifespan of 8 to 10 years, the annual cost is only about $2,000 to $2,500. With the ability to operate 24 hours a day, 7 days a week, each robot could log over 8,000 working hours per year. That works out to a labor cost of only 25 to 30 cents per hour. By comparison, the current U.S. federal minimum wage is $7.25 per hour, not including insurance and benefits. This makes Optimus at least 24 to 28 times cheaper than unskilled labor in developed markets. At large-scale deployment, the productivity impact will be clear. In a factory, a human worker operating 8 hours a day produces output X, whereas an Optimus can sustain production 24/7, potentially tripling the output of an equivalent human role. Robots are unaffected by illness, weather, strikes, or vacation time. An assembly line with 100 Optimus units could match the productivity of 300 human workers, maintaining a steady pace year-round. Economically, producing 1 million Optimus units annually at $20,000 would generate $20 billion in yearly revenue for Tesla, not including income from maintenance, software, and upgrades. More importantly, it would create an entirely new industrial infrastructure: factories for frames, small electric motors, sensors, batteries, drive systems, and AI training data centers for robots. Each Optimus would require ongoing software updates and training, opening a recurring revenue stream from service fees or software subscriptions, a model Tesla has already mastered with its EV business. The real-world applications of Optimus span many industries. In manufacturing, an electronics plant running 24/7 with Optimus could lower unit costs by 30 to 50%, boosting competitiveness against factories in low-wage regions. In logistics, robots could load, pack, and move pallets continuously, reducing order processing times from hours to minutes. In healthcare, a hospital with 50 Optimus units assisting with nursing support and materials transport could significantly ease the workload for nurses, allowing them to focus more on direct patient care. In construction, Optimus could work in hazardous environments, carry heavy materials, and reduce workplace accidents while maintaining round-the-clock progress. 1 million robots per year means that after just 5 years, there would be around 5 million Optimus units in the market. This figure represents about 1.5% of the global workforce, but since each robot can work roughly 3 times the hours of a human, the effective productivity would equal around 15 million full-time workers. This would sharply boost global productivity, but also mean that some unskilled jobs would disappear rapidly. Tesla holds a significant advantage in mass production thanks to its Gigafactory system. A single Gigafactory can currently produce hundreds of thousands of EVs annually. If the same optimized processes are applied to Optimus, combined with automation, reaching 1 million units per year is achievable. Musk has hinted that Optimus could be assembled in the same facilities as EVs, leveraging existing supply chains for batteries, electric motors, and controllers, thus greatly reducing new capital expenditures. Standardization will also be key. If Tesla produces a base Optimus model that can be customized via software, production costs will drop quickly thanks to economies of scale. This is exactly the strategy the Model T employed: minimal options, mass production, continuously falling prices, and exploding demand. The widespread adoption of Optimus will drive infrastructure changes. There will be a need for more robot charging stations, real-time fleet management systems, and local maintenance service networks. Software companies will develop applications enabling Optimus to take on more specialized roles, from restaurant service and tour guiding to operating complex production lines. On a global scale, a cheap, high-productivity robot workforce could reshape supply chains. Companies could relocate production closer to end markets since labor cost differences would no longer matter, shortening delivery times and reducing the risk of disruptions. This could erode the competitive edge of countries that rely on low-cost labor, forcing them to shift toward higher value-added industries. Once again, please help us reach 15,000 subscribers. This is important for us to stay motivated. Thank you. What new industries could emerge with the arrival of Optimus? When Tesla launched its first electric cars, many believed they were just a niche product, unlikely to disrupt an automotive industry dominated by internal combustion engines. Yet in less than 15 years, Tesla not only sold millions of cars, but also spawned an entirely new ecosystem: large-scale battery manufacturing, a global fast-charging network, energy management software, and autonomous driving services. The Optimus robot could generate a similar Tesla EV effect, triggering the birth of entirely new business sectors and jobs that do not exist today. Optimus is not just a work tool, it is a hardware platform. Much like how smartphones became a platform for millions of apps. Once millions of Optimus units are deployed, the demand for industry-specific function customization will explode. This paves the way for a robot app economy, where developers could sell software that teaches robots to cook, repair machinery, guide tourists, or assist in patient rehabilitation. If each robot can install dozens of paid skills, the robot software market could reach tens of billions of USD annually. Alongside this, a new industry will emerge for AI training services for robots. Optimus is equipped with sensors, cameras, and powerful processors, but to excel at a specific task, it will require dedicated datasets and specialized AI models. Companies could offer robot training services on demand. For example, teaching a robot to stack goods in a 3-story warehouse, or operate a specific brand's CNC machine. This creates opportunities for thousands of startups and local AI centers, similar to how coding boot camps proliferated during the internet boom. Beyond software, the hardware accessories sector will also expand. Optimus could swap out grippers, attach tools, or add sensors for specialized jobs. This market could resemble the car accessories or smartphone accessories industries, but on an industrial scale. One company could specialize in agricultural grippers, another in underwater sensors, and another in off-road wheels for construction sites. Another new field will be robot fleet management and coordination. When a company operates hundreds or thousands of Optimus units, it will need intelligent scheduling systems, performance monitoring, fault detection, and priority-based task distribution. This will be the domain of companies providing operating systems for robot fleets, similar to existing platforms for managing truck fleets or construction machinery. Even in education, Optimus could spark new career paths. Vocational schools might offer courses like Service Robot Technician, AI Trainer for Robots, or Robot Behavior Programmer for Industry. At the K-12 level, students might learn to interact with and program Optimus as a basic skill, much like office computing skills are today. The social impact of Optimus could also lead to unconventional jobs. For example, the entertainment industry might use robots as supporting actors or behind-the-scenes assistants. Sporting events could have Optimus units serve as line judges or capture footage from hard-to-reach angles. Even the personal care industry might hire robots as in-home assistants, giving rise to Optimus rental by the hour, a new kind of sharing economy. In terms of scale, the economic potential of these new sectors is enormous. McKinsey estimates that each wave of disruptive technology can create accompanying services and software worth 2 to 3 times the value of the hardware itself. If Optimus sales generate $20 billion annually, the supporting ecosystem, from software, accessories, and training to services, could reach $40 to $60 billion annually, not counting spillover effects into other fields. One key difference is that this wave will be more decentralized than EV adoption. While EV charging infrastructure is concentrated in large cities and along highways, Optimus services could appear anywhere, from rural woodworking shops and small urban stores to farms, hospitals, and schools. This allows job and business opportunities to spread widely, not just in industrial hubs. Tesla will also be unable to do everything alone. Just as with EVs, They will need partners to develop software, design accessories, and provide training and maintenance. This opens the door for both large enterprises and small startups to participate in the Optimus value. A local company might specialize in short-term robot rentals for projects, while a software company in another country could sell skill packs for robots through a global app marketplace. The arrival of Optimus could also enable industries that are currently non-viable due to labor shortages. For example, offshore wind turbine inspection services often struggle due to dangerous conditions and high labor costs. With Optimus, a dedicated robot inspection and maintenance service could emerge, reducing costs and scaling up rapidly. Which creative jobs will thrive when Optimus takes over repetitive tasks? When the GigaPress appeared, the auto industry was forced to almost redefine the concept of assembly. A car frame that once had to be pieced together from hundreds of parts could now be cast in a single shot within seconds. The result was lower costs, shorter production times, and workers freed from repetitive tasks so they could take on more complex roles. Optimus could deliver a similar effect, but not just for one industry, rather for the entire landscape of human labor. Imagine a warehouse operating with 50 workers, each fixed at one station, repeating the same task for an entire shift. When Optimus is introduced, it takes over nearly all manual labor, lifting, packing, inspecting goods, even cleaning at the end of the day. People are not laid off en masse, as many fear, but moved into roles requiring thought and decision-making, optimizing workflows, caring for customers, developing new products. Just as the GigaPress freed workers from minor assembly steps so they could focus on quality finishing, Optimus will free us from draining jobs so we can devote our energy to creativity. The strength of Optimus lies in its ability to work continuously, consistently, and without fatigue. An office employee could focus on new product ideas without also having to sort files or haul equipment for events. A chef could spend more time experimenting with new recipes because the robot handles prep and dishwashing. Creative work, from fashion design, content creation, and scientific research to event planning, all benefits when the heavy and time-consuming parts are handled by Optimus. When the burden of physical labor is reduced, mental strain decreases as well. Gallup research shows that people who do work they enjoy are 31% more productive and 3 times more creative than those stuck in work they dislike. Optimus could be the catalyst to make this statistic commonplace. Instead of spending 8 hours drained by petty tasks, people devote most of their workday to ideas, strategies, and new solutions. This not only improves the quality of work, but also changes the pace of life. When repetitive tasks are assigned to robots, a 4 to 6 hour workday becomes feasible while maintaining or even boosting productivity. The extra time can be spent on learning, personal entrepreneurship, or simply rest. In the long run, this is the foundation for moving society closer to a creative economy, where value comes from ideas and experiences rather than hours of manual labor. Notably, Optimus is not confined to industrial settings. In households, it can take care of chores so the owner can focus on writing a book, learning a language, or researching a personal project. In agriculture, it can handle harvesting and transport, freeing farmers to spend more time experimenting with new crop varieties or refining cultivation methods. On a societal scale, the shift from manual to intellectual labor will accelerate innovation across all fields. Some fear that when robots take over tasks, people will lose basic skills. In reality, when the GigaPress automated many steps, mechanics didn't lose their jobs. They learned new skills to manage, maintain, and optimize the production line. The same will be true with Optimus. We will need to learn how to manage robots, assign tasks effectively, and use the data they collect to improve processes. Tesla will spend more than $500 million to expand its fast-charging network this year. Elon Musk once said, and now Tesla has proven it. Imagine over 1 million Tesla cars and Optimus robots sharing a single charging station. Fast-charging technology allows the robots to recharge 3 times faster than before in just 30 minutes, almost eliminating any waiting time. So, how will Tesla combine charging for both cars and Optimus Gen 3.5? Before we begin, please help us reach 15,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. What can a shared charger do for Tesla and Optimus? When Tesla began branching out from electric vehicles into the humanoid robot space with Optimus, an interesting question emerged. How can these two siblings charge in the most compact and cost-efficient way? The most logical answer might be, let them share the same charging system. Sounds simple, but the benefits are far from small. First, there's the matter of money. A 250 kilowatt DC fast charging station, according to ICCT's 2023 report, costs anywhere from $35,000 to over $100,000 to install, depending on location and electrical infrastructure. If Tesla were to go big and build a dedicated network for cars and another for Optimus, costs would nearly double. Suppose a factory needs 10 charging points for cars and 10 for robots, each costing about $50,000, totaling $1 million. But if both cars and robots share the same 10 stations, adding only an adapter and management software, the total might drop to around $550,000. A simple calculation shows nearly 45% savings, and at a scale of hundreds of cars and robots, this is no small figure. Next is the question of space. Each fast charger takes up about 4 to 6 square meters, not counting space, for maintenance and operation. If separate systems were built for cars and robots, the footprint would double. In a factory or warehouse, every few dozen square meters are highly valuable, potentially used for production lines or storage. With shared infrastructure, Tesla could deploy dock-style chargers or even wireless charging pads usable by both vehicles and Optimus. This could cut the charging footprint by half. Operationally and in terms of maintenance, things would also get easier. Data from ChargePoint shows each fast charging station costs roughly $400 to $1,200 annually to maintain. Halve the number of stations, and maintenance costs drop accordingly. Technicians would only need to manage one unified system, reducing confusion and allowing quicker troubleshooting. Tesla's strength in blending software with hardware makes flexible charging allocation easy. For example, during the day, chargers could serve EVs, and at night, Optimus robots. A smart scheduling system could prevent queues and downtime. In fact, the shared infrastructure model isn't new. Airlines share gates and ground services. Logistics firms share cold storage. The goal is always the same: cut costs and maximize resource use. Tesla could do the same, adding automated recognition and dynamic power adjustments for each device type. Of course, there will be challenges. Tesla EVs use the NACS port, while Optimus might require a smaller connector, so adapters or compatible docks would be needed. Cars demand high charging power, 150 to 250 kilowatts, while robots only require a few kilowatts, so software would need to balance loads to avoid overcapacity or waste. When both urgently need power, the system must prioritize without disrupting operations. If these issues are solved, shared charging could become a strategic move, saving money, saving space, and boosting operational efficiency. This wouldn't just optimize today's operations, but would pave the way for Tesla's long-term ecosystem vision, where everything from cars to robots is seamlessly connected and powered. Currently, Tesla has quietly tested prototype charging stations capable of serving both EVs and Optimus robots at some internal research facilities. A source from Fremont revealed the system uses Tesla's NACS standard combined with an automated charging mechanism that connects to Optimus's port without human intervention. This shows Musk isn't just talking about ideas. His engineers have been working on it early to shorten the path to deployment. If successful, Tesla could roll out thousands of these stations at Giga Texas, expected to be the hub for both car and robot production. Economically, shared charging infrastructure could slash costs dramatically. Building two separate systems would double spending on electrical hardware, cables, energy management units, and upkeep. Combining them not only reduces hardware needs, but also lowers staffing and long-term maintenance costs. Internal estimates suggest shared charging stations could cost 35 to 40% less than separate ones, while enabling expansion 1.5 times faster. With 1 million Optimus robots planned in the coming years, the savings could reach billions, a figure no company would ignore. Strategically, Musk aims for an ecosystem where every device, from the Model 3, Cybertruck, and Semi, to Optimus, speaks the same energy language. This reduces costs and locks users into Tesla's ecosystem, much like Apple did with the Lightning charger. Once Optimus drinks from Tesla chargers, customers will be further tied to the brand, needing only one infrastructure to power both vehicles and robots. The long-term vision stretches further. If these charging stations become a global standard, Tesla could allow other robot or EV manufacturers to pay for access. Just as they opened NACS to Ford, Rivian, and others, Tesla could turn the charging network into a steady revenue stream. Every robot or vehicle charging would generate income for Tesla, whether it's their product or not. This is exactly the hardware plus service strategy Musk has often emphasized. An intriguing aspect is priority-based smart charging. For example, at night when car demand is low, stations could prioritize charging Optimus robots so they're ready for work the next morning. During peak morning hours, the system could shift focus back to cars. All of this would be controlled by AI-driven energy management software, optimizing every kilowatt hour to keep all devices running smoothly. Zooming out, shared charging for Optimus and Tesla vehicles is part of Musk's grand connectivity map, where robots, cars, energy storage, and renewables are all synchronized, automatically managed, and waste minimized. This is key to producing 1 million Optimus units without hitting an energy bottleneck. If each robot needed its own charging source, costs and setup times could seriously slow expansion. All of this fits perfectly with Musk's approach at Tesla. Build a common platform, squeeze every bit of value from each dollar spent, and turn infrastructure into a lasting competitive edge. If the plan works, we could see a global network of chargers not just for cars, but as energy pit stops for millions of service robots worldwide. Once again, please help us reach 15,000 subscribers. This is important for us to stay motivated. Thank you. How does fast charging technology from electric cars transfer directly to robots to minimize waiting time? Optimus Gen 3.5 is not just a hardware upgrade. It marks a major leap forward in charging infrastructure and energy management. The key highlight is that Tesla has applied its fast charging technology, originally designed for EVs, to the robot, but refined to meet the continuous operational demands of Generation 3.5. Whereas previous versions required around 2 to 3 hours to fully charge, Gen 3.5 can reach 100% in under 60 minutes. This enables the robot to maintain an almost uninterrupted work cycle, a critical factor as Tesla aims to produce and deploy 1 million units. This charging speed far surpasses many competitors. For example, Figure AI's Figure 02 requires roughly 2 hours of charging for 5 hours of operation, while Agility Robotics' Digit takes even longer, limiting its ability to work long shifts. By contrast, Optimus Gen 3.5 can replenish enough energy for 8 to 10 hours of runtime in just 45 to 50 minutes with a high-power charger. This is a massive advantage for robots working 24/7 in manufacturing or logistics environments. Tesla is also testing an interleaved charging model, in which robots automatically move to the charging station when their battery drops to 15 to 20%, then return to work without human intervention. With a synchronized charging system, 100 Gen 3.5 robots in a factory can rotate between charging and working, boosting overall efficiency by 20 to 25% compared to the previous generation. This not only minimizes downtime but also optimizes operating costs for businesses. Another important improvement is charging station compatibility. Elon Musk has revealed plans for Optimus Gen 3.5 to use the same charging standard as Tesla EVs, NACS, meaning factories, warehouses, or service centers can share charging infrastructure for both electric vehicles and robots. This dramatically reduces upfront investment. Considering that a single fast charging station costs an average of $35,000, shared infrastructure could save millions of dollars when deploying thousands of robots. The Gen 3.5's battery has also been refined for higher energy density, with a capacity of around 2.3 to 2.5 kilowatt hours, but 15% lighter than Gen 3. This improves both charging efficiency and operating time. Notably, Tesla has integrated an active thermal management system to keep battery temperature stable between 20 to 30 degrees Celsius, even during fast charging, extending battery life to over 3,000 cycles, equivalent to more than 8 years of daily charging. Beyond hardware, Tesla's intelligent charging orchestration software plays a decisive role. Gen 3.5 connects to a fleet management system capable of predicting energy demand based on workload and automatically scheduling charging times to prevent station overload. This mirrors how Tesla coordinates superchargers for millions of EVs worldwide, but scaled down and optimized for factory and service environments. From an economic standpoint, Gen 3.5's fast charging capability reduces non-productive time, thereby improving return on investment (ROI) for customers. For example, if a robot loses 2 hours per day to charging, over 1 year that's more than 700 hours of lost potential production. With Gen 3.5, That figure drops to under 200 hours, saving tens of thousands of dollars per robot annually, not to mention the impact when scaling to hundreds or thousands of units. The charging technology in Generation 3.5 also opens the door to outdoor and remote operations. Tesla is testing mobile solar-powered charging stations, enabling deployment of robots at construction sites, farms, or areas with incomplete infrastructure. This greatly expands the potential market beyond traditional manufacturing. Clearly, Optimus Gen 3.5's strength lies not only in task execution or agility, but in how Tesla has optimized the entire energy chain, from the battery and charging stations to intelligent scheduling software. By combining fast charging infrastructure sharing with EVs and automated charging coordination, Gen 3.5 becomes the only robotic platform today capable of continuous operation at million-unit scale. This positions Tesla for absolute market leadership, turning charging technology into a strategic lever for dominating the global robotics industry. Why manage energy between Tesla and Optimus? One of the most overlooked yet transformative innovations in Tesla's ecosystem is its intelligent energy management system, which seamlessly allocates electricity between electric vehicles and Optimus Gen 3.5 robots. This technology is not just about charging. It is about creating a unified energy network where power flows intelligently to wherever it is needed most, ensuring maximum operational efficiency. At the heart of the system is Tesla's proprietary software platform, originally developed for balancing power distribution in large-scale supercharger networks. In the past, this technology was primarily used to manage high-demand EV charging stations, ensuring each vehicle received the optimal current without overloading the grid. With Optimus Gen 3.5 entering the picture, Tesla has adapted this capability to manage two fundamentally different but equally energy-dependent products: cars and humanoid robots. The intelligent energy management system constantly monitors battery health, charge levels, and usage patterns of both the EV and the robot. For example, if a Tesla Model Y in a household is at 80% battery capacity and an Optimus Gen 3.5 is running low at 20%, the system can automatically prioritize sending more electricity to the robot without manual intervention. This dynamic allocation prevents downtime for either device and ensures that both remain ready for operation when needed. This is particularly valuable for businesses or facilities where both Tesla EVs and multiple Optimus Gen 3.5 units operate simultaneously. A factory floor equipped with a fleet of Tesla delivery vans and a team of Optimus robots can avoid bottlenecks in charging schedules. Instead of competing for limited power resources, the intelligent management system orchestrates a smooth energy flow, charging some robots while EVs are idle, then switching focus when vehicles require more power for upcoming trips. Another key advantage lies in load balancing. By analyzing grid demand in real time, the system can schedule charging sessions during off-peak hours, reducing electricity costs while avoiding strain on local infrastructure. This approach mirrors Tesla's time-based control feature for EV charging, now extended to cover robots. The system's AI-driven algorithms learn user routines and predict when each device will require energy, further improving efficiency. For households, the integration with Tesla's Powerwall and solar roof adds another layer of autonomy. Solar-generated electricity can be allocated between the EV and Optimus Gen 3.5 according to priority settings. If the household's daily needs are modest, but the robot is scheduled for intensive cleaning or heavy lifting tasks, the majority of solar energy can be diverted to the robot. Conversely, if a long road trip is planned, the system can preemptively shift more energy toward the vehicle in the days leading up to departure. The technology also offers safety benefits. By intelligently controlling the charging sequence, it prevents both the EV and the robot from drawing maximum current at the same time, reducing risks of circuit overload. Additionally, continuous monitoring allows the system to detect abnormalities in charging behavior, such as unexpected voltage drops, and take corrective action before they escalate into hardware damage. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.